Hi, everybody. Today we are going to start working on arithmetic sequences, which is a specific kind of number pattern, like kind of what we saw yesterday, but just with a little bit more specific rules. Um, yeah, we'll do a couple of formulas. We'll talk about some different types of problems I'm going to ask you to be able to do, and then you'll be done. The learning target that we are focused on today is learning target 9A, which says I can use explicit and recursive formulas to write terms in a sequence. It also says I can write and use formulas to find the nth term of arithmetic and geometric sequences. We're going to focus on just the arithmetic sequence formulas, so only this stuff. We will be doing both parts of this learning target, so let's jump into it. Arithmetic sequences is the focus of today. And so arithmetic sequences are number patterns and they follow adding rules. And so when we look at these, this means there is the same thing that we add each step. And so what is the thing that we are adding each step in this first example right here? We are adding 3 each step. So the thing that we're adding is 3. So because it's the same each time, that makes this an arithmetic sequence. This one is also arithmetic. And we can see that because we are adding the same thing each step, but the thing we're adding is negative. So we're adding a -6. And so each step, it looks like it's going down by 6, but what we want to say is we're adding -6 each step. And that thing that you add every step has a vocabulary word. It's common difference. And so when we are looking at these common differences, we use the letter D, D for difference. And so we said that D was 3 in this example, and D was -6 in this example. So it's important that we can find the common difference in a number pattern. So make sure you know how to do that. Make sure that you can use your calculator if you need it to figure out what you're adding each step. You can kind of use a little guess and check for now and go from there. All right. Now we have some formulas to explain sequences. So earlier we had number patterns written out and we identified the common difference. And now this time we're going to use a formula that I give you, and then we're going to try to write out the first 5 terms. So the type of question that I would be asking you would say, write the first 5 terms of the sequence. First, I want to kind of talk about a little bit of what do all of these things on the screen mean. And so I'm going to start with the A. And the A is just the name of the sequence. The little numbers next to the A, like these, and then all of these, are those step numbers. So we can say n is the step number. And so if I'm looking for A3 is the third term in the sequence called A. So now let's start. Let's find the first term in the sequence. So it says A1, we're looking for A1, but it says A1 is 8. So we can just write that A1 is 8. The next one says we're looking for A2. And in A2, it says, okay, well, the step number is 2. And so we're going to put in a 2 wherever we see an n. So we'll rewrite that. A n is 2. 2 minus 1. Then it says plus 3. So then I need to figure out, okay, what does this whole thing mean? What does this mean? Because this looks new to me and I haven't seen this before. Well, 2 minus 1 is 1. And so I could rewrite this blue stuff as A1. And A1 plus 3 looks a little bit easier because I know what A1 is. A1 is 8. Is 8. And I know that 8 plus 3 is 11. So I can conclude, I can say, now I know that A2 equals 11. Okay, let's do A3. A3 says, okay, now n is 3. Okay, so A3 minus 1 must be the same as A2 plus 3. And then I know that A2 is 11, so I can just write 11 plus 3. And I know that 11 plus 3 is 14. Okay, let's do the next one. We're looking for A4, so we go A4 minus 1, and then it says plus 3. So then, to figure out what A4 minus 1 is, well, 4 minus 1 is 3, so I can write A3 plus 3. Well, what's A3? Well, A3 is 14. It says it right here. So then plus 3. And what's my answer? I get 17 out. Okay, now let's take a look at our pattern. How do we go from 8 to 11? How do we go from 11 to 14? And then 14 to 17? And then I wonder if we can use that to figure out what A5 is. And so I noticed that the common difference, the thing we add each step, is 3. Each step. I noticed that it shows up in my formula. And so I think I should use it to figure out the next step. And so my next step is 20, because 17 plus 3 is 20. Go to the next slide. You're going to have one that is exactly the same as this one. You just have to use the different numbers. So follow exactly the same process. Use exactly what I did here. You can literally just copy it, but with the new numbers for the next problem. In this one, the formula looks pretty different to me. I noticed that there's only one line. There's no squiggly thing like that. And so I think I have to do something a little bit different here. Remember that the B is just the name of the sequence. And then the N is the step number. And so that's here, 2, 3, 4, 5, 5. And then the N is here. And check this out, it actually shows up in the formula this time. So that means we're going to be putting in the step number into the formula while we're evaluating. So what I'm going to do is I'm just going to write out the whole formula a couple times. So I'm going to look at what B1 is. Excuse my voice crack. Whoa. So I'm going to rewrite the whole thing. 43 minus 4 times N in this one says 1. So we write 1 minus 1. Do the same thing, 43 minus 4. This time N is 2, so we need to write 2 here. Keep on going. N is 3. And one last one, let's just do one more, 43 minus 4 times, okay, N is 4 minus 1. Okay, so notice that what I'm doing here is I'm taking that N, which is the step number each time, and putting it into the formula where it belongs, right there. Okay, now we have an evaluating thing. So if you have a fancy calculator at home where you can put parentheses in and stuff, and it's not just your phone calculator, you can type this whole thing in. You can also use desmos.com/calculator. Okay. that will allow you to just type the whole thing in. That is perfectly fine with me. The other thing you can do is make sure you follow the order of operations. So order of operations says inside the parentheses, we have to do the 1 minus 1, you get 0. Then you got to do the multiplication, and so you get 4 times 0 is 0. Then you got to do the adding and subtracting. So then you do 43 minus 0, and you get 43. Let's do it again, just to make sure. 2 minus 1 is 1. Do the multiplication. 1 times 4 is 4. 43 minus 4 is 39. Let's do one more. 3 minus 1 is 2. 4 times 2 is 8. 43 minus 8 is 35. What is the pattern here? Well, let's just do one more just to make sure. I want to make sure we get in the routine of following the order of operations and making sure that we are being careful about our answers and making sure our answers make sense. 4 minus 1 is 3. 3 times 4 is 12. 43 minus 12 is 31. All right, what is our pattern? We are adding -4 each step. Remember that I always want to write these arithmetic sequences as an adding rule because that is my definition of an arithmetic sequence. So I want to be consistent about how I do that every time. So what do I got to do to get from 31 to step 5? I got to add -4. And so what is my answer? It is 27. Perfect. Now on your screen, there's going to be one that is exactly the same as this, just with different numbers. And I want you to try to identify, well, what is the common difference? And write out the first 5 terms. Okay, so now let's see what we have. What we have right now is we have 2 different kinds of formulas. And if you look carefully, you can see that they all kind of have the same stuff in them. So let's figure out what all of these things mean. We have seen that our A1 is our first term. That's the thing that the sequence starts with. It's the first thing that you see on the list. The N we've been using a lot. N is our step number. And so AN is the nth term in sequence called A. Okay, so if 3 is the step number, A3 is the 3rd term in the sequence. A5 is the 5th term in the sequence. The last thing that we need to label here is the letter D, and we already said that the letter D is the common difference. I would pause this video. I would, in my notebook, write this whole slide down. I would write every single thing on the slide, and I would label it arithmetic sequences. So the reason that I say that is because you're going to use these formulas both all day today and later in this unit. So I would make sure that I have this written down somewhere. So I would, if I were you, I would just go grab my notebook right now and I would write arithmetic sequences at the very top of the first page, and I would write recursive and explicit, and then I would write the 2 formulas, and then I would also write all of this important information about what these things are. Right below where you wrote your work, your labels of all those formulas and everything, I want you to try this problem. I want you to write the 2 formulas for this sequence. And so what you need to do is you need to identify A1, which is the first term, and D, which is the common difference. Once you have that stuff, you can just copy down these two sequence formulas exactly the way they're written, except instead of writing first term, or A1, you write what the first term is. And instead of writing D, you just write what the common difference is. So try that right now. And now let's do it together. So A1 is my first term, and my first term is 14. D is the common difference, and it's the thing you add each step. And so we're adding -1 each step. And so D is -1. Now we can use our formulas to write these out. So my recursive formula looks like this. A1 is, well, 14. And to get any step, you go to the previous one and you add -1. You can take all of this information and just copy it down except for changing this and this every time. That works just fine. Our explicit formula is we have to take exactly the same steps. We just change our A1 and our D to what we know they are. So AN equals A1 is 14, D is -1, there we go, all done. In this problem, this is like the kind of ultimate end of what we're going to do today. This one says, find the 78th term of the sequence. And so what we need to do is we need to write an explicit formula. For the sequence. And so we need to figure out, well, what is A1 and what is D? We're going to use the formula AN equals A1 plus D times n minus 1. So take a second, write out what A1 and D are. And now let's write our explicit formula. So we get AN equals, well, what is A1? A1 is 95. What is D? D is what you add to get to the second step, so -2. We're adding -2 each step. So D is -2, so we rewrite. Whoops, there, okay. So if I wanna know what the 78th term is, I need to find out what A78 is. But A78, now N is 78. So we can put 78 in for N and see what we get out. So A78 is equal to 95 minus 2 times 78 minus 1. I want you to use your desmos.com/calculator, or I want you to just use the order of operations to evaluate this thing, figure out what your answer is. What did you get? Well, 78 minus 1 is 77. 77 times 2 is 154. So 95 minus 154 is -59. So the 78th term of the sequence is -59. There is one almost exactly like this coming your way on the next slide. When you are done with that, you are done for the day.